Hi everyone, in this video I'm going to talk about the business analytics project that was undertook by group 14 as part of the business analytics course in IIM Calcutta. Let's go to the business context. SouthWest Airlines is launching a new flight status portal for its customers. The portal will provide real-time flight status to its customers, and the airline empowers aims to empower its customers by providing reliable expectations about delays and cancellations. This will have twofold benefits both for the customer as well as Southwest Airlines. The customers will be able to make well-educated decisions on cancellations and better manage their travels. Southwest Airlines, on the other hand, will get information about the cancellations well in advance, allowing for better management of flight bookings and operational decision making. This business context has some business objectives, and the first step of our project was to map our business objectives to analytic objectives that we can undertake that we can find. So the business objectives in this case are to decrease operational cost incurred due to unforeseen delays and cancellations, as well as the role of weather in those delays and cancellations. And second, improving transparency among customers by notifying them about delays well in advance. Both of them can be achieved by these two analytic objectives. The first one would be to predicting delay times on different routes. This would be both the departure delays and the arrival delays, as well as predicting the probability of cancellation of flights to provide clear indicators to customers to make informed decisions. To achieve our analytic objectives, we undertook analytic analysis of a data set that contained flight information coupled with weather data. Our first step was to pre-process and clean this data. This involved handling missing values in the dataset, uh, redefining some columns, and exploring the data. Some of the things that we found from the data exploration are these graphs. So the arrival delay of any aircraft is usually centered around zero. Uh, Most of them is very close to zero, but we do see some large tails for some flights. Similarly, we have this graph that gives the distribution of arrival delays with respect to the departure delays. And as you can see, there is a clear correlation between them, indicating that when a flight has a departure delay, it usually has an arrival delay as well. So we have done many more data visualizations in uh, the Jupyter notebook, and these were two of them. Uh, so after performing these data visualizations, we created multiple models to achieve our analytic objectives. As I just mentioned, our uh, analytic objectives was to predict the departure delay, arrival delay, and the probability of cancellations. The prediction of departure and arrival delays would be done using regression models, while the probability of cancellation would be done using classification models. The team or the group uh, experimented with multiple different models ranging from linear regression to decision trees to random forest to bagging models and even neural networks. And all of these models were fine-tuned and hyperparameters were trained, and we compared these models and uh, and drew some insights from them. So these were the results of this model. The As you can see, we created each for each of the three analytic objectives. We have multiple models. The first uh, two tables indicate regression models, while the third one indicates classification models. Uh, the best model to predicting departure delays was the sequential neural network. We did experiment with non-sequential neural networks as well, but we saw that the sequential neural network was giving the best departure delay estimations. Also, the arrival delay prediction models, in this case, the linear regression model did the best. And for the case of uh, probability of cancellations, we found that the bagging classifier, which was made using a bag of logistic regression models, did the best. Although the precision and recall were not that great, but they were the best among the other models that we trained. Finally, we would use these models to solve our business objectives and uh, give a dashboard similar to this to the customer, where the customer would be presented by three numeric metrics. The first one would be the expected departure delay, and this would be predicting using the sequential neural network model. Expected arrival delay using predicted using the linear regression model, and the probability of cancellation predicted using the bagging classifier model. This dashboard aims to provide transparency and an estimation to the customer so that they can make more informed decisions and this would in turn benefit Southwest Airlines as well. Uh, so this was our project. For this, we have created multiple Jupyter notebooks that outline different models that we created and different analysis that we undertook. We also have a report that we have submitted along with the model files as well. So that would be it. Thank you.